see? So this guy is from task 1. Okay, so we have 3 water bath temperature, and then you have 3 absorbance reading, and then in here, what do we do? So the first column, I say 1 over temperature, and the unit is 1 over Kelvin, okay? So finally, I gave up. I tell you the answers on the x-axis label, so you should do both. 1 over temperature, parenthesis 1 over Kelvin, all right? So do both in the x-axis label. So 1 over 283, whatever that number may be. How many sig fig we should have?
7.
3. So 283, that's 3. Well, I mean, 1 is a perfect one. So of course 1 is 1 sig fig, but then that is not counting, it's inverse. So should be at least 3 sig fig, all these numbers. Now, then you have your absorbance of 5. So each one you divide by 5,000, or your slope of the graph from task 1. Then you have this column C. And then your thiocyanate equilibrium concentration, it would be 2 times 10 to minus 4 divided by 2, so it's 1 times 10 to minus 4. And then you subtract C, so each subtract C. And the KEQ would be just like that equation. So equilibrium of the complex and divide by the product, reactant, excuse me, the reactant, the 2 reactants. So C divided by A times B. So this is your A, this is your B. Then you got different equilibrium constant, because equilibrium constant is what? Temperature sensitive. So it's not a perfect constant. So it would change as you change temperature. So we have how many KEQ? Would be 4, because it's 4 temperatures. Once you have 4 KEQ, now this could be still headache. Why? 0.1 is pretty big number. Subtract C, so this most likely is a positive number. But this one may be trouble, because 1 times 10 to minus 4 is 0.0001, pretty small number. And you subtract C, if C is a big guy, then you get a negative number. If you get a negative number, your KEQ will be negative, which is no meaning. And again, don't be smart and change sign or anything. Don't do that. Leave it alone. And then you cannot natural log a negative number. Then we have to skip that part. Okay? Ideally, we should have 4 pieces, but somehow, sometimes we may get 1 bad data point, then we end up with 3. Okay? Then we're going to make the graph and natural log of KEQ on the y-axis, 1 over temperature in the x-axis, and you make the graph, and delta H is minus 1. Again, I write it out in here somehow. Sometimes students do something else, all right? So minus 1 times the slope of the graph, and 10 times the gas constant, 8.314. That will give you delta H. Again, I didn't spell out the units in here, so you make sure add units. And the delta S would be y-intercept of the block times R. Now, according to the publication, the delta H should be negative, so that means it's exothermic, according to the publication. But this one is conflicting. Some students observe just endothermic, some exothermic. I don't know why, but just follow your data. Don't change. Anything? Once? Twice? So that will be the worksheet and the graph. Make sure you have the good title, right title. Yeah. Well, just take a quick look of this graph title. What would be the title? Where you get that from? That will be on page 116, 116. Task 3, right? This is task 3. If you read number 7.7, generate a Van Hoff plot. So your title of this graph should be what? Van Hoff. But Van Hoff is not good enough by itself. I mean, that's the name of the person. But you should add what? The reaction of that, you see? So on top of Van Hoff. But you must say Van Hoff for sure, okay? Because that's the plot we ask you to generate.
And put what on top?
Huh?
What on top?
You should say Van Hoff plot for the reaction of iron plus thiocyanate. See what I mean? Okay. Okay, so I think that's it.